Hello everyone, now we have to discuss reciprocity theorem. The statement for this reciprocity theorem is, in a linear, passive, bilateral network, the ratio of response to the excitation is same even when the positions of response and excitation are interchanged. Even the voltage source is present in left hand side, we have to calculate the current at right hand side. Later, we have to replace that voltage source into right hand side, then we have to calculate the current in the left hand side. Then we have to check the response to the excitation ratio of the first case should be equals to the response to the excitation in the second case. Therefore, reciprocity theorem is verified. That is the statement for this reciprocity theorem. For that statement, in a linear, passive and bilateral network, the ratio of response, that is nothing but output, right? The ratio of response to the excitation is same even when the positions of response and excitations are interchanged. So, the ratio of response to the excitation should be equals from first case to the second case. That is, if we consider a circuit, this is the network. Okay. The network, we have a plus minus, we have a voltage source V1. So, through this we have a current I1, like that this is network 1, like that we have a network 2. So, this is V2, for example, this is the current through this branch is nothing but I2. So, this is what? Excitation, right? This is what? Response, output. Here this is excitation, this is response. Then read the statement. In a linear, passive and bilateral network, the ratio of response to the excitation. So, from this, from network 1, like that, from network 2. See, then read the statement. In a linear, passive and bilateral network, the ratio of response to the excitation. So, from this network 1, what is the ratio of response to the excitation? Response is what? I1, excitation is what? V1. I1 to the V1 is same even when the positions of response and excitations are interchanged. So, coming to the case 2, here the excitation position changes, right? Like that, response position also changes. Interchanged, their positions are interchanged. That is why here also response is I2 by V2. Then statement, it should be equal even though their positions are interchanged, those ratio of response to the excitation should be equal. These two are equal, that is I1 by V1 should be equals to I2 by V2. This is reciprocity theorem. This is a statement for reciprocity theorem. Let us discuss some problems based on reciprocity theorem. This is the first problem. So, here the excitation is 10 volts, response is 20 amps, and those positions are interchanged. Here the excitation is 10. What is the response? Right? So, I1 by V1 should be equals to I2 by V2, right? This is the statement for reciprocity theorem. So, here I1 is what? From this 20 by 10 should be equals to I2, we do not know. By what is the value of V2? V2 is also 10. So, from this I2 is equals to what? 20 amps. Same amount of current through this branch. So, like that, see, here I1 is 1, I1 by V1 is equals to I2 by V2. Therefore, what is the value of I1? 1 by 5, which is equals to I2 is what? We do not know. V2 is 10. So, from this I2 is equals to what? 2 amps, right? I2 is equals to 2 amps. See, here the current is 2 amps, right? See, excitation 1 is 5 volts, V1 is equals to 5 volts, like that. V2 is equals to 10 volts. Means what? Here the excitation is scaled by 2 times. That is why output current also scaled by 2 times. Scaled by 2 times. Means what? Principle of homogeneity. This is the concept of principle of homogeneity. X giving you y, kx giving you ky, that is it. This is principle of homogeneity. Next problem is show the application of reciprocity theorem. So, this is the circuit A, this is the circuit B. See, here the excitation is what? 10 volts. Sorry, here he provides, you have to calculate the current through this branch, right? See, here the excitation 10 volts, we have to calculate the current through this branch. Like that, this is the same circuit, but the excitation and responses are interchanged. Here the excitation is 10 volts, we have to calculate the current. Means what? We have to verify this reciprocity theorem. That is, we have to verify. See, what is the response to the excitation? The current between these two terminals, right? Current between A and B. The response to the excitation is what? Vxy, right? Between these two terminals should be equals to, from this, what is response? Ixy should be, sorry, Ixy divided by VAB, that is it. If we prove this statement, then verification of the reciprocity theorem is completed. Then, so we have to calculate the current through this, that is it, right? This is V, like this is V. Simple. From circuit A, V minus 10 by 2 plus V by 3 plus V by 3 is equals to 0. From this 3V minus 30 plus 2V plus 2V, 4V, which is equals to 0. 7V is equals to 30, V is equals to 30 by 7. Therefore, we have to calculate the current through this branch. Therefore, I is equals to what? V by 3, which is equals to 30 by 21. I is equals to 1.43 amps. The current is 1.43. Current is 1.43. That is I1 is 1.43. V1 is what? 10 volts. That is it. Like that, from circuit B, from this V by 2 plus V by 3 plus V minus 10 by 3 is equals to 0. From this 3V plus 2v minus 20 is equals to 0, 2v plus 2, 4v, 7v is equals to 20, v is equals to 20 by 7. Therefore, we have to calculate the current I2, right. This is I1, I2 is what? This one, v by 2, which is equals to 20 by 14. Therefore, I2 is equals to what? 1.43 amps. Like that, V2 is 10 volts. See, from this, I1 is 1.43 by 10, I2 by V2 1.43 by 10. Those two are equal. Hence, reciprocity theorem is verified. That is it. If you take any circuit like this, you have to solve. Okay. Next problem is, so from this circuit we have to calculate the value of I2. I2 is what? So, we have excitation 1, response 1, we have excitation 2, response 2. See, here the excitation 1 is 4 volts, excitation 2 is what? 20 volts. It is scaled by what? 5 times. 4 into 5. It is scaled by 5 times. Means what? Here we have the homogeneity principle, right. So, I1 by V1, which is equals to I2 by V2, right. But see, here it is plus minus, but here minus plus. What is that meaning? Opposite to polarity, polarity opposite to main voltage source. That is why you should consider minus 20. I1 is what? 8 by 4, which is equals to I2, we do not know. V2 is what? Minus 20. Why minus 20? See, here we have plus minus, here minus plus, which is opposite to this voltage source. That is why we have I2 should be equals to minus 40 amps. That is it. Answer is over. Next, we will discuss some limitations of reciprocity theorem. So, it is applicable only to single source networks. Only this theorem can be applicable for single source networks only, not for multi source network, not for multi source network. The network where reciprocity theorem is applied should be a linear one and containing R, L and C circuits only. So, that is why it should be stated in the statement, in a linear passive bilateral network. The network should not have any time varying elements. So, these are the limitations for this reciprocity theorem.